Okay, today, guys, we are on day 4 of factoring, and we're still going to be factoring trinomials. If you understood how to factor any trinomial from yesterday's lesson, you really already have learned how to do our lesson for today. The difference with what we're going to be doing today is we're not necessarily going to be working with trinomials with a leading coefficient of 1. So anytime we have a trinomial that doesn't just start with x squared by itself, 1x squared, maybe it's 2x squared or 5x squared or something like that, you must do it the long way. You cannot use the shortcut to factor. So pretty much what we did yesterday, the way we did these first 5 problems, the very original example, and then problems 1, 2, 3, and 4 using grouping, that's what you're going to have to do. You're not going to be able to shortcut it like we did 5 and 6 because the leading coefficient on the squared term is not 1. So these are the same steps that we talked about yesterday. Remember, after we check for our GCF, we're going to do our AC product. Make sure you put the AC product right here in the top. The product always goes here. Make sure you put the middle term, the sum, right here, because that's what we're asking ourselves. What numbers multiply to this product but add to this middle number? And then we come up with those outer and inner terms so that we can break this up into 4 terms. Okay, so let's start with this first one here. In this first example, it actually does start with 1x squared, so you really could shortcut it. But what freaks us out about this is it has x and y in it. So I've just always told my students, when that happens, let's not trick ourselves, and let's just go ahead and do it the long way. So we first start, is there a greatest common factor? No. Next step, 1 times 42. Well, 1 times 42 is 42. So we're trying to find what 2 numbers multiply to positive 42, but add to this middle number of positive 13. And if you go through your factors of 42, 1 and 42, 2 and 21, 3 and 14, or 6 and 7, we would realize that the correct factors for this one are going to be 6 and 7. If you're struggling finding all the possible factors of a number, a quick shortcut would be to use your calculator. If you go in your calculator and you take your product, so in this case, since our product is 42, and you have to divide it by x, and then go to the table, what happens is as you look through the table, starting at 1, it'll give you all the factors. So we could write them down, 1 and 42, 2 and 21, 3 and 14. Of course, any numbers that give you a decimal, those are not factors. So we wouldn't put 4 or 5. And then we have 6 and 7. And then you see 7 and 6. So you would stop right there because they're now switching places. So you already have those factors. You can also do this using Desmos. In Desmos, you would just type y equals 42 divided by x. And then remember, you come right in here, click your bolt, duplicate this over here, then make it into a table, which I've already done. And then what you'll just have to do is just keep pressing enter on the table. And again, once I get to 6 and 7, right here, I wouldn't need 7 and 6. And if you want to, any that came out to be decimals when you're done, you could just go and delete them so that you could just look at just those factors. And again, I don't need 7 and 6 because I already had 6 and 7. Hopefully you know your multiplication tables, but this is just a strategy that may be helpful, especially if you have really big numbers and they have lots and lots of factors. Okay. So what we're going to do is now break this into 4 terms. So our first term is going to be x squared. We're going to rewrite this 13xy using 6 and 7. So we're going to say plus 6xy plus 7xy. Remember, that is because those would add back to 13xy. Everything we write is equivalent. Plus 42y squared. And then we're going to use our grouping method. So we group the very first 2 terms. And we say, what does x squared and 6xy have in common? They have an x in common. So we factor out the x, and we're left with x plus 6y. Remember, if the third term starts with a plus, we will have a plus here. If the third term starts with a minus, we're going to have a minus here and factor out a negative. And then we ask ourselves, what does 7xy and 42y squared have in common? Well, 7 goes into both of them, and so does y. So when we factor out that 7y, we're left with x from the first term, and then 42y squared divided by 7y is 6y. Again, you can use some foreshadowing. If you get the first group correctly, you kind of know, what do I need to divide the next 2 terms by so that I am left with x plus 6y. Make sure your 2 parentheses are exactly the same. put your GCFs together in a group, and then put your common group beside it. Remember, you only have your common group once, not twice. Technically, the order you write these factors in doesn't matter. If you wrote x plus 6y and then x plus 7y, it would be correct also. Both answers are correct. You can always check this by boxing or foiling back. Actually, while we're on this topic, you can factor using the box method. It's not traditional and you probably won't see it happen a lot, but I do want to go over it. It may help some of you. What you would have done is you would have still done the AC product step. You still would have found these factors of 6 and 7. But then you would have drawn a box. In the top left corner, you would have put the first term of your trinomial. So we would have put this 1x squared right here. In the bottom right corner, you will put the last term of your trinomial, the 42y squared. And then this 13xy, once you get these numbers 6 and 7, you would put those in these diagonal corners and they should add to 13xy. So I could put 6xy here and I could put 7xy here, or vice versa. It really wouldn't matter. And then what you're doing is the opposite of what you did when you did the box method. You would say, okay, what does x squared and 6xy have in common? What is their greatest common factor? I'm looking at this first column right here. Well, I can see that both of those are divisible by x. All right, so then if I came over here, 7xy and 42y squared, what is the greatest common factor between those two terms? It would be 7 and also y. So then you again can do some foreshadowing. You could go to your first row and you could figure out the greatest common factor, or you could just say, well, what did I have to multiply x by to get x squared? Oh, well, it must have been x. You can just think about it like that. Also, if you look at it, x squared and 7xy, their greatest common factor is x. And then same thing here. If you've already pulled out the x, what did I have to multiply x by to get 6xy? Oh, 6y. Also, 6xy and 42y squared, the GCF is 6y. So then you would take these, and if it's positive right there, that must have been plus. It's positive right here, this must have been plus, and then you would create your factors. So if you like that method better, you can try it out. All right, let's check out the next one. So the first step is we're going to say, does it have a greatest common factor? And in this case, it does not. So the next step is we're going to say 2 times 3, and 2 times 3 is going to give us positive 6. So we are trying to find what numbers multiply to positive 6, but add to positive 5. Okay, again, if you list your factors of 6, they're 1 and 6 and 2 and 3. 1 and 6 will not work because they both would have to be positive if this whole trinomial is positive, and that would add to 7. You can't make the 1 negative. But 2 and 3 does work. So if we use our grouping process, we will copy the first term, 2x squared. We rewrite this 5x as two terms using the factors we just found. So plus 2x plus 3x, and then we copy the last term. We draw a line right after the second term before the third sign to use our grouping method. So what do the first two terms have in common? 2x. And then when we factor the 2x out, we are left with x plus 1. Remember, there is a 1 left here. Some students will think there's nothing. There has to be a binomial. If you started with 2 terms, your binomial, your parentheses here, still has to have 2 terms. 2x divided by 2x is not 0, it is 1. And then we come over here because that's plus, this is plus. What does 3x and 3 have in common? 3. When you divide both of these terms by 3, we are left with x plus 1. So our 2 GCFs is 2x plus 3, and then our group, our common group is x plus 1. Notice I cannot shortcut here. It will not work. If I was to think I could shortcut, I would have had, oh, I have x, and then in the back I would have put plus 2 plus 3. Folks, that does not work. If you multiplied those back out, positive 2 times positive 3 is positive 6, and the last term is 3. That is wrong. We can only use that shortcut method if that leading coefficient is 1. So that's why I was saying yesterday, some of y'all might just never want to use the shortcut method. You might just want to always do it the long way because that way you don't have to think about it. You could also try the box method here if you like that method better. So again, what I would do is I would draw a box. I would put the first term in the top left corner and the last term in the bottom right corner. I would use these numbers, 2 and 3 that I found, to rewrite 5x. So I could put the 2x here and the 3x here, or it could be the opposite. It doesn't matter. What does 2x squared and 3x have in common? Oh, an x. What does 2x and 3 have in common? Only a 1. Again, if you think there's nothing in common, they do have 1 in common. So what did I multiply x by to get 2x squared? 2x. Or you can look at it as 2x squared and 2x have 2x in common. What did I multiply x by to get 3x? Oh, 3. Or you can look at it as 3x and 3, their greatest common factor is 3. This whole thing's positive, so this is positive, positive, and then you have your factors. All right, try the next two. Pause the video. When you're finished, start the video back. All right, so for this first one, we should have 7n minus 1 and n minus 1. And again, if you wrote your answer as n minus 1 and then 7n minus 1, that is also correct. Because it all depends on which way you ordered those middle terms when you did your factoring. So yours may be a little different from mine, but in the end, we should get the correct answer. Now, if you're liking the box method better than the grouping method, let me point something out here. When we go to this first row and we say, what does 7n squared minus 7n have in common? We should see that that would be 7n. When you go to the next row, anytime the first term is negative, you have to factor out a negative. That's the key. If the first box you get to is negative, no, you have to factor out a negative. And then what is the only thing that negative 1n and 1 have in common? You can kind of just ask yourself, what would I have multiplied 7n by to get 7n squared? N. What would I have multiplied 7n by to get negative 7n? Negative 1. But again, if the first term is negative, you got to factor out a negative. And the only thing that 7n and 1 have in common is negative 1. And then you could put them together to write your group. Coming over to this next problem, I didn't quite finish it because I wanted to point something out. Again, one of the struggles students have is they see this and they don't think that there's anything in common. 5a plus 1. Oh, well, it's not divisible by anything. Yes, it is. It's always divisible by 1. If nothing's in common, they have 1 in common. Because that first term's positive, we'd put positive 1 right here. And then that would be 5a plus 1. So our factors would be a plus 1 and 5a plus 1. Guys, there's no reason for anybody to get these wrong because you can always check these by boxing or foiling back or using the distributive as long as you do all 4 multiplications. So if I just wanted to check this real quick and make sure that I have the correct factors, I would know if I truly check it and don't look at your answer. I'll see students check it and I'm like, you just wrote down what you already had to make it work. Pretend like you can't see the problem and really check it. What's a times 5a? 5a squared. What's a times 1? 1a. What's 1 times 5a? 5a. What's 1 times 1? 1. When we combine our like terms, that gives us 5a squared. 5a plus 1a is 6a plus 1. Yes, that is what we originally had. We know we have the correct factors. All right, try the next two. Pause the video. When you're finished, start the video back. Okay, so for number 5 here, I did it both ways. I did it where I broke it up and put plus 1n, then plus 6n, and the second way where I put plus 6n and then plus 1n. The next step is different because of the way they ordered them, but what you can see is in the end we have the exact same factors because the order the factors are written in does not matter. 2 times 3 is the same thing as 3 times 2. So don't worry if your work's a little different than mine as long as you're getting those factors in the end. So if any of y'all got stuck on number 6, there's a reason for it. When we multiply 3 times 6, we get the product as positive 18, but it adds to negative 7. And the only way you can have two numbers multiply to a positive but add to a negative is if both numbers are negative. So as I go through and list all my factors of 18 and make both of them negative, none of them add to negative 7. If I look right here, negative 1 and negative 18 would add to negative 19. Negative 2 and negative 9 would add to negative 11. And negative 3 and negative 6 would add to negative 9. And what a lot of students want to do here is they want to make this 2 right here positive, this negative 2, they want to make it positive 2. But then if I tried that, if I said, oh, well, let's use positive 2 and negative 9, they wouldn't then multiply to give us positive 18, so that's not possible. This is a very special case, and it rarely happens, but what we would do for this one is we would say this trinomial is prime. And what that means is its only factors are 1 in itself. It's just not factorable past that. It didn't have a greatest common factor other than 1, and there are no factors that would multiply to give us that trinomial. All right, pause the video in just a second and try the last two. Remember, always look for greatest common factor first. All right, so number 7 is special because it does have a greatest common factor. And we get in a bad habit of not looking for those greatest common factors because they don't always have one, but that's always got to be the first step. Once we factor out that 3, we're left with 2t squared minus 1t minus 6. 2 times negative 6 is negative 12. And we want to find the two numbers that multiply to negative 12 but add to this negative 1 here in the middle. So as we go through our factors of 12, we know that one's going to have to be positive and one's going to have to be negative. Obviously, if it adds to a negative, the bigger number's negative, and the ones that would work here is negative 4 and positive 3. And always check and make sure that that works. One of the common mistakes students make is they let this 3 fall off their paper. So what I would do is I would carry this down and go ahead and put it down here and create your 2 sets so you make sure not to leave that 3 off the front. All right, let's factor out what we have left. So we have 2t squared minus 4t plus 3t minus 6. And then we draw our line. The first two terms have 2t in common. And when we divide both of those terms by 2t, we are left with t minus 2. This is a plus here, so we copy that plus there. The next two terms have 3 in common. When we divide 3t minus 6 by 3, we are left with t minus 2. So our two GCFs is 2t and plus 3. We put that in the group, and then we put our common group beside it, t minus 2. Again, you can always check it by foiling, boxing, or distributing these two binomials out and then distributing the 3 in the end. The last one was kind of a special case because when you're done, you end up with two binomials that are exactly the same. And that answer is perfectly correct, nothing wrong with it. But you also may see that written like this, 2x minus 5 quantity squared. Because remember, anytime we see a binomial squared, we should write it twice and FOIL, box, or distribute. All right, so last part. Today you're going to have an assignment in Delta Math. The only thing is, in Delta Math, so I'm going to pull this up real quick. All right, so in Delta Math, let's just say you had this problem, 5x squared plus 31x plus 6. We would work it out, use our grouping method, do all our steps, and the answer would be x plus 6, 5x plus 1. Or you might have 5x plus 1, x plus 6. But let's say that when we type this in, let's say we accidentally have the wrong answer. So I'm going to purposely type this in wrong. 5x plus 6, oops, x plus 1, which I know this isn't the right answer, but let's say you messed up and that's what you have. Okay, so I submit this and it tells me I'm wrong. Here's the problem. It will tell you the correct answer, but the way it explains how to do it is a guessing check method, which is much harder than the way I've taught you how to do it by grouping or by box method. And I wish I could fix this for y'all, but I can't. Of course, it would tell you what the correct answer was. It would tell you what your solution was and tell you what the correct answer is. It's just the explanation of it. I mean, you can see what the two terms are, but they're using more this like backwards FOIL guess and check method, which it's difficult for most students. So I just want y'all to understand that as you do the program, that the explanation, if you're getting it wrong, is going to be a little bit awkward. So you're better off to go back to what you learned. You can see what the correct answer is, and you can see what those terms would have been to break down, but go back to what we have been doing in our video to do these problems. All right, good luck, and tomorrow you're going to do a little assessment on GCF, factoring out the GCF, factoring by grouping, and factoring trinomials.